All right, so we're starting chapter 6. We're going to talk about the law of sines today. Yeah, we're almost done. Almost done with this semester, and then we won't have to do trigonometry again. All right. So what we're going to be doing in this first part of this section, first part of chapter 6, is the idea is we're solving oblique triangles. And what we mean by oblique triangles is rather than working with triangles that have a 90-degree angle, our triangles don't have any. What we're doing will work for 90-degree triangles with 90-degree angles, but we have other methods that we use for those. So most of our triangles aren't going to have 90-degree angles, is what oblique triangles mean. So we want to apply what we figured out about trigonometry to figuring out things about other triangles that don't have 90-degree angles. And we talked about it briefly before. We did some when we talked about right angle trigonometry. When we say solve a triangle, we're solving for all the sides and all the angles. So we're finding all sides and angles. And what we're doing with the law of sines, what we'll end up doing with the law of sines and law of cosines, we'll start with one side and two other parts of the triangle. So we'll have a side and two angles. We'll have three sides. So we'll have some combination of parts, and we're going to apply the law of sines or law of cosines to find out the missing parts. So we're going to use the law of sines in a couple of cases. So law of sines when we have two angles in any side. I should say we have. And we're going to apply it to, if we remember back, I know geometry was a long time ago, we're going to apply it when we have angle, angle, side, or angle, side, angle. We're going to apply it to angle, side, angle triangles and angle, angle, side triangles. So if we have two angles and a side, or an angle and the side between them, that's when we're going to use the law of sines. On Monday we'll talk about another case when we use the law of sines where we have to be a little more careful. When we're working with triangles, again, just a reminder, we talked about it before, but the way we label triangles is if we have some triangle, like so, we label the angles with capital letters. So we call the triangle ABC. And the side opposite the angle we label with small letters. So that would be side A, side B, and small c. So this is how we're going to label our triangles for this unit. Okay, so the law of sines. I'm going to write the law of sines down, and then we'll show why the law of sines works, and then we'll do a couple of examples. So this is our triangle. The law of sines says that side A over the sine of angle A equals side B over the sine of angle B, and that also equals side C over the sine of angle C. So we can use any combination of these two, or these three, sorry, any two of these three to come up with an equation. We can also write this. We can take the reciprocal of everything. We can flip everything. We can say or. Sometimes it's more convenient to do it with our signs on top and our sides on the bottom. Doesn't matter. The reason you would use one over the other is depending on what parts of the triangle you have. One's easier, then it makes it so you have a little less work to do to solve for the part that you're looking for. So that's a law of sines. Pretty easy to remember. Let me show you why the law of sines works with I'll just do one pair of these, and then we'll do some examples. And the last thing that we'll do today is show how we can use the law of sines to find the area, a formula for the area of any triangle. So, why it works. It's kind of nice, kind of slick the way it works out, the way we do it. So what I'm going to do here is I'm going to take my triangle, and we like to call triangles ABC, and I'm going to draw in, this is side B, this is side A. I'm going to draw in the height of the triangle. So here's my height. And the height makes a 90-degree angle with this base. So this is a 90-degree angle. And we'll call this H. So now we've divided our triangle into two right angles. I can write an equation for the height. The height is the opposite side from angle A, and I also have B as the hypotenuse. So I can say that that the sine of A equals H over B. The sine of this angle is the opposite over the hypotenuse of this right triangle. So now I'm going to solve this for the height. So if I get the height by itself, H equals B sine A. Now I'm going to look at this triangle. From this triangle, sine B is the opposite over the hypotenuse, H over A. So if I solve for H here, I get H equals A sine B. I have two different equations for H, but they're both, since they both give me H, I can say that B sine A equals A sine B. And if I divide both sides of the equation by length B, and divide both sides of the equation by length A, I just have to rearrange this a little bit, and I get sine A over A equals sine B over B. So I just divided my triangle into two right triangles and found an equation for the height using two different right triangles. And that's what gives me one pair of the equations from the law of sines. And I could draw height for all of the different sides and do the equations for the height using each different side, and that would give me a different pair of the equations that we wrote for the law of sines. So I can just do this repeatedly to get the other equations for the law of sines. So this is why the law of sines works, because I can draw this height and then use what we know about right triangles to find the height. Does that make sense? All right. Let's do a couple of examples where we're finding, finding missing parts of triangles using the law of sines. So the way that your problems are normally going to be written for the law of sines is it'll tell you some angles and sides. A equals, for this example, 123 degrees. B equals 41 degrees. And side A equals 10 inches, we'll say. And what else do we have? We want to find, for this problem, it tells us find side C. So what I suggest when you do problems with law of sines is always sketch out a little triangle. So this is 123 degrees. It doesn't really matter how you sketch it. So I'm going to say this is A, B, and C. So it says this angle is 143 degrees. Angle B is 41 degrees. And we want to find side C. Yes? 123, thank you. All right, so we have two angles. We have an angle, side angle, triangle. So how do we want to go about, what do we want to do to solve this? What? Yes? We can find angle C. So we can figure out that angle. Angle C is 180 minus 123 plus 41. So I'm just subtracting the two angles. Yes? Okay. So angle C turns out to be 16 degrees. Yes? Yes, because we have this side. So we can say C, we're solving for this, C over sine of 16 degrees equals 10 over sine of 123 degrees. I can solve for, I can get side C by itself, just multiply both sides of the equation by sine of 16 degrees. So I get C equals sine 16 times 10 over sine of 123. You can plug that all into your calculator, and this turns out to be approximately 3.29. So from here, I'm just plugging everything in my calculator and calculating. Another thing to remember when we're using law of sines is almost the opposite of what we did with other trigonometry. We're always going to be in degree mode. When we're talking about triangles, we normally talk about the angles in degrees rather than radians. When we're talking about the unit circle, we usually talk about radians, but when we're talking about triangles, we're talking about degrees. So, this example was pretty easy. It just asked for one side. The pair of equations that you use for the law of sines just depends on what sides and what angles of the triangle that you have. If the problem had asked us to solve this triangle, we could then have also found side B using the same process. Questions on that one? Okay, let's do another example, and then we'll talk about how we find area. And it's related to the law of sines. All right. So for this one, we have A equals 95 degrees. We have angle C equals 68 degrees. we have the side between A and C, angle A and C is 115 yards long. So we could be talking about a triangular plot of land or something. So the side between A and C is 115 yards long. We want the length of the other two sides. So let's draw our sketch. So here is A, B, and C, and it says A is 95 degrees, C is 68 degrees, and the side between angle A and C is 115 yards long. So I'm going to call this 115. So we have another angle side angle triangle. And we want to find the other two sides. So what can we do? How can we go about this? Isn't this the same as the one we just did? Find the angle. So our angle B would be 180 minus 68 plus 95. So angle B is 17 degrees. So we can find our angle B. And then we can just pick out a pair of equations to use to solve for other sides. So this is side A, this is side C. So why don't we start with side A? So we can say A over the sine of 95 equals 115 over the sine of 17. So A equals, multiply both sides by the sine of 95 degrees. 95 degrees times 115 over sine of 17 degrees. Plug this into our calculator, and we get that A is about 391.84 yards. And we can do the same thing for side C. I can say C, and I can pick any pair of sides and angles that I want, as long as I have all the pieces that I need. So I can say C over sine of 68 degrees equals, and I'm just going to use this same thing here, 115 over sine of 17. We've already calculated that, so if you calculate that once, you could have it in your calculator, you could have it written down. C, multiply both sides by sine of 68 times 115 over sine of 17 degrees. Plug that all in and calculate, and I get about 364.96 yards. So when we have an angle side angle or an angle side triangle, using law of sines is pretty easy. Find our angles, use a pair of our equations, and calculate the parts that we're missing. Questions on this? All right, let's talk about how we use what we know here to find areas. areas of oblique triangles. And our formula is going to come from the same setup that we used to show why the law of sines works. So here's my oblique triangle. I'm going to draw in a height again. So we'll make that a red dotted line here. And we'll label our triangle ABC like we like to. And we'll call this the height. So what's the formula for the area of a triangle? Yeah, that was right. Area equals 1/2 the length of the base times the height. So for this particular triangle where we drew in our height, what is the length of the base? What side of the triangle would be the length of the base for this triangle? C, right? So our area equals 1/2 C, and then we're going to calculate our height. Well, we can calculate our height because we know that this is a 90-degree angle. We can say that, just like we did before, that H equals B sine A. Just like we did before, we have this right triangle. Our height is B sine A. So I can plug this in over here for the height. The area is 1/2 C times B sine A. And the way we normally write this is 1/2 BC sine A. So if we have an angle and we have two sides, an angle, side, angle, triangle, we can find the area of that triangle. We could go through the same process and draw our heights in for our other sides and do our other calculations. And we end up with three formulas that we can use for the area. So we can use the same argument and say that the area equals 1/2 AB sine C, 1/2 BC sine A, and that is also 1/2, which combination are we missing? AC sine B. So depending on which combination of sides and angles we have, we can find the area of a triangle. All three of these will give us the same answer. It just depends on which combinations of sides and angles we have. And it all comes from calculating the height, just like we did before, because we divide this into two right triangles. That makes sense where it comes from? Okay, so let's look at one example of finding an area, and then we'll be done. So let's say we have, we want to find the area. And our triangle has B equals 143 degrees. C equals 7. And B equals 18. Let's see, did I write this down wrong? This should be A. A equals 7. All right, so we can sketch out a picture. So here's my triangle. I'll call this angle B, since this is a bigger angle. We can call this A and this C. So A is 7 and B is 18. So this would be our triangle. But from our formula, we know that our formula is area equals 1/2 AB. Should be, what am I missing here? AB. It should be sine C. So let's see, did I set my problem up wrong? Yeah, this should be A, and this should be a C. A and C and assign B. So this is A, C is, there we go, C is 18, and angle B is 143. So we have 1/2 AC sine B. So we just plug these numbers in. Our area is 1/2 7 times 18 times the sine of 143. Plug that into my calculator, and I get that the area is about 37.91 square units. Questions on that? All right. So hopefully you find a lot of signs easier than solving trig equations. Okay, homework. Page 416. And then, sorry, I'm going to go backwards here a little bit. These are the area problems here, these three. All right, there you go.